Hi guys, hope all of us are doing fine. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. In this particular discussion, I'm going to look at a sample question on the concept of moments. And in our last discussion, I had basically mentioned that the concept of moments is going to be very significant in our various applications under statistics, whereby we are going to come across the relationship between a representation of moments and the concept of population or sample variance and other aspects of the arithmetic mean, as we're going to see later. So in this case, we are going to use this sample data which I've given on the board, and this is going to form a simple example for us in trying to represent perhaps the first moment, the second moment, or the arbitrary moment of a particular value about a specific number that we're going to look at. So in this case, if we may have a small a reminder of what we have discussed in our previous discussion. I'd said that suppose we have a specific value of x, we can give different, of course, values of this specific variable in terms of x1, x2, perhaps xn, and this can be given in terms of, or we can be able to describe the mean of these specific values using this particular representation, whereby we're going to have it represented as such. So therefore, we have said that we can define the nth moment of this specific set of data given in terms of x bar raised to power r, or to power r, given as a summation of x1 r plus x2 r plus all the other values which are going to be ranging from 1 to n. And of course, this is going to be divided by the number of this particular distribution given as such. So in this case, this is going to be reducing to a form of the summation between I is equivalent to 1 to n of x I, and this is going to be represented as xi r all over n given as such. And this is going to give us the general formula for representing this the nth moment of a particular distribution given us, or a particular values for the variables of particular values for x1, x2 to xn given as such. And I've said that this particular number for I is 1, 2, to n given as such. So this represented a general case for finding the moment or the nth moment which was defined as such. And we had said that we can consider the case for the frequency distribution, whereby we see that this nth moment can be represented in terms of the summation from I is equivalent to 1 to k, the frequency, and then we are going to have this one given in terms of x, of course, I, r, and then we are going to have this one divided by n given as such. So in this case, we had given different variations for these specific sets of course, moments, whereby we said that if we are going to substitute the value of r is equivalent to 1, then therefore the formula is going to reduce to a simple arithmetic mean. And in some cases, we had, of course, referred to this one as the first moment. So in this case, we looked at various variations of the nth moment about the mean, whereby we had given also a general formula for the nth moment about the mean given in terms of mr. And for a frequency distribution, of course, we have said that this one can be given, or for a raw data, this one can be given in terms of this summation of I is equivalent to 1 to n of the values of xi minus the mean. And this is going to be given as the nth moment given as such. So this formula as well gave us specific variations, whereby we had considered the case of this one as well equivalent to n minus 1 over n. And then we had this one as the summation between 1 to n over x I minus x, the mean. And this one was all over n minus 1 given as such, as another way of trying to represent the nth moment about the mean. So as well, we said that if we are going to assume this particular formula for this, and of course we're going to have this having an implication of the value of r being equivalent to 2, and perhaps if the value of n minus 1 is approximately the same as n, this is going to give us the concept of what we refer to as, of course, the second central moment, which basically gave us the population variance and the sample variance in that particular case. Now, generally, we had said that as well from our last discussion, we can define an rth moment about another number given in terms of MR is equivalent to the summation of I is equivalent to 1 to n of that specific set of values for variable x minus a given as such, and this is going to be given as all over r minus 1. Now, we are given a similar formula for, of course, a frequency distribution, whereby we included the frequency, and that formed our last bit for the specific discussion we had from our first video. Now, in this case, we're going to use the data which I've given on my right side of the board in trying to, of course, evaluate single moments and the first or the second central moment about the mean as I mentioned. So in this case, we're going to look at this. And of course, if we are requested to find perhaps the moment of the following data, then therefore we're going to use the general formula in trying to find the moment of xr is equivalent to the summation of I is equivalent to 1 to a value of n xi raised to power r all over n given as such as our general formula for finding an rth moment in that particular case. So if we are required to find perhaps the first moment in this particular case, we're going to represent it as x1 given as such, and that is going to be values of the summation of I is equivalent to 1. And of course, this is going to, so the value of n in this case for a particular set of data like this one is going to be 1, 2, 3. So therefore, we're going to consider that specific aspect of 3, and therefore we're going to have this one as x I. And of course, if the value of the first moment, then therefore r is equivalent to 1. Therefore, we're going to have this specific set of data given as such. Therefore, this is going to be given in terms of the summation of these particular values for 2 plus 3 plus, of course, 7 divided by 3 given as such. So this is going to be the numerator is going to form a summation of these particular values, and this is going to represent our first moment given as such. So this is going to give us the value of 4. And basically, as we said, whenever r is equivalent to 1 for this rth moment, this is going to give us the arithmetic mean of that particular kind of moment. So in case we are requested to find the second moment, we are going to have this particular r equivalent to 2, and therefore this formula for us is going to be given in terms of this particular aspect of the second moment, which is equivalent to the summation between I is equivalent to 1 over nx, of course, raised to power 2 given as such, and this is going to be all over 3. So therefore, this is going to be having an implication of the summation of these specific values, but these values are going to appear in terms of squares of 2 squared plus 3 squared plus 7 squared all over 3, and that is going to give us the value for this one, which is 20 point, perhaps, okay, you can confirm from that. So the second moment, rth moment, the second moment where r is equivalent to 2, of course, is going to be given in terms of 20.67, and of course that's going to be a way which we're going to evaluate specific evaluations. So if we're requested to find the rth central moment, which of course we had defined using the mean. So I'm going to use the general formula which we had defined for the central rth moment, or the moment about the mean, which was given in terms of mr is equivalent to the summation between I is equivalent to 1 to m of values of this particular variable x minus the mean given as such, and that was given as over r raised to power r over n. And in this case, of course, we're going to do a substitution for this particular value. So if r is equivalent to 1, therefore this is going to be the summation between I is equivalent to 1 to 3 of values over x minus 1. So this is going to be the difference between these specific values for 2, 3, and 7, and the difference with the mean, implying that we are going to have this one as 2 minus the mean. Now the mean for these particular values from our first calculation was 4. So this is going to be given as such. So plus, so the summation means the addition. So therefore we're going to have 3 minus 4, of course, plus this is 7 minus 4. And this is going to be giving us the value. So this is going to be divided by 3. So negative 2 plus negative 1, this is going to be negative 3. Negative 3 plus 3 is equivalent to 3 over 3. So of course, negative 3 plus 3 is equivalent to 0. So this is going to be 0 divided by 3. And of course, the earth central moment, which is going to be R equivalent to 1, is equivalent to 0 in that particular case. So next we can, of course, calculate the, the earth moment where R is equivalent to 2 by having this one, of course, the difference between this one raised to a particular power of R, and that is going to be giving us the various moments. So in our last case, of course, we had mentioned that we can find the earth moment about a particular number, and in that case we had given A as an arbitrary number, whereby this earth moment about a particular number was given as the summation between I is equivalent to 1 to n, and then we had the difference between that specific variable and the number given as such raised to power n, r over n. And of course, in this case, given a particular number, perhaps A is equivalent to 3, we're going to do a substitution for this specific value for A is equivalent to 3, and then we're going to do an evaluation for that one in order to find perhaps the first, the second, and the third moment, just similarly to the one that we have done. So suppose we are requested to find perhaps the third moment about this specific number that we have given for is equivalent to 3. We're just going to do a direct substitution for this one, and this is going to give us a value of m is equivalent, or m3, or the third moment about this one, and that's going to give us the values of the summation of these differences between this specific value and A. So this is going to be 2 minus 3 plus 3 minus 3, and this is going to be raised to power 3 plus 7 minus 3 raised to power 3 all over. So the value for n is equivalent to 3, and this is going to give us the value of 21. So the third moment, earth moment about a particular value A is going to be, of course, equivalent to 21. And that's how we're going to do various evaluations of this specific aspect of the moment which are basically promised. So that is it for now, guys. Bye, God bless you. Catch us in our next video.